So now we just finished with the base units, so we're going to move right along to some derived units. And you'll see there's a little bit of a difference with the derived units. Let's go right ahead to the next slide. If you look at derived SI units, we're still talking about System International System units, and we're dealing with derived units. They are, and actually let me see if I can get rid of this, area. The area, if you recall, the formula for area is length times width. So since it's length times a width, that's really like two lengths. We're talking about meters times meters. So notice how by knowing the units or the formula for area, you can know either or, then we know both formulas. The unit for area is meters squared, and notice that basically tells us what the formula is, length times width. So that's kind of how we derive the SI units from that base unit. The second derived SI unit is volume. And I would imagine, again, you can think of different volumes, you can think of liters or whatnot. We'll get to that, but the derived SI unit, again, deriving them from the base unit, is length times width times height. Again, realistically, they're all lengths anyway. So the derived SI unit for volume is meters cubed. Again, a length times a length times a length. In essence, you get meters cubed. The third derived unit is force. And again, if you know your freshman science or physics, force is mass times acceleration. Again, both mass and acceleration. Mass is in kilograms or grams. Acceleration is in meters per second squared. So the formula for force is derived from the base units. We're going to use a unit, though, called the Newton. So again, named after Isaac Newton, the Newton. Moving to the next derived unit, pressure. Pressure is also named after another scientist. Again, it's derived. I won't worry about how it's derived, but again, it's called the Pascal. Again, named after scientist Pascal's. The next derived unit is energy, and the derived unit for energy is the joule. And again, these are probably all units that you've seen before. I would assume in some of your physics or freshman science classes, joules. Moving along, the derived unit we're going to talk about now is power. Power, we would probably have some ideas that it is the W, or in other words, watts. Watts is our derived unit for power. The next one is voltage, probably a really tough one to figure out. Volts. Volts is the SI unit for power. Volts is the SI unit for voltage. The next one, frequency. Frequency is in hertz. And that's really cycles per second. It's how quickly a wave moves up and down. And lastly, our derived SI unit for electric charge, and that is in a big capital C, coulombs. Coulombs. Actually, I may be spelling it wrong here. It doesn't really matter. It's my classroom. Coulombs. Okay, so those are your derived SI units. We're going to move really quickly now to some non-SI units that we are going to use. They are metric based as well. We have volume. Volume in a non-SI unit is in liters. The next non-SI that we're going to see very commonly in here is temperature, of course, in degrees Celsius. Pressure is in two different units. We can see that in atmospheres or mmHg. mmHg stands for millimeters of mercury, and again, those are two non-SI units that we're going to see commonly for pressure. And lastly, energy, and I would imagine you understand that calories can be used for energy, whether that's food energy, food calories, etc. It's neither here nor there. So let's now move quickly to another slide, and then we'll finish up this second section. The next slide is going to deal with a laser action for you right there. Metric prefixes. And there are so many metric prefixes. I know, obviously, now with the computers we have gigabytes, and well, if I talk about megabytes first, then gigabytes, and now terabytes. Obviously, these are units that are super large. We're going to be dealing more with the smaller ones. So if you want to follow along in terms of our metric prefixes, I'm going to first talk about the base unit, And the base unit would be where you have your meter or gram or second or Pascal. It doesn't matter what it is, but that's the base unit. And the base unit, of course, is to the ones place, the meter, 1 meter long. If I go to scientific notation on that, it's 10 to the 0 power. Scientific notation or exponential, however you want to describe it, 10 to the 0 power. I'm only going to do 2 units that are larger than the base, and again the giga or tera would fit in here, but I'm just going to do the kilo, which of course is abbreviated with a K, and the kilogram, kilometer, kilosecond, whatever it might be, kilopascal, is always 1,000 times larger than the base, which 10 to the 3rd power. I'm a bigger fan of using the exponentials, 10 to the 3rd, and you'll see why I describe that in just a minute. After the kilo, we have the mega. And again, for computer folks, you know the megabyte, megapixels, whatever it might be. Mega is 1 million times. I think I've got a million right here. And again, that's 10 to the 6th power. Those are the only ones I want to talk about in terms of larger than the base. We're going to do more through the smaller, the first being the deci. Obviously, like a decimeter, deciliter, whatever it might be, the abbreviation for that is D, and that is 1/10. So 1/10 the size of a meter is a decimeter. That's 10 to the -1. Exponential -1, of course, is 1/10. Centi, next, abbreviation C, that's 1/100th, 10 to the -2. Milli, centimeter, millimeter, milli abbreviated M. I'm not going to worry about the 1/1000th. It's just 10 to the -3. Moving along quickly, micro is a funny looking M. It's kind of like a U looking M. It's the Greek symbol for the lowercase mu, and that's what our micro is. And that is 1 million times less the size of a base unit. So a microgram is 1 millionth of a gram. Nano is an N, and that's 1 billionth. So 10 to the -9. That 9 didn't come out very good. Let's take a look at that again. -9. And the last one is a picogram, picoliter, etc. And that's a lowercase p, 10 to the -12. I want you to see, before we move on, I want you to see just really quickly how we're seeing that I gave you more of the smaller, fewer of the larger, just because we're in the chemistry classroom. We're going to be using more of the smaller things. We talk about atoms, sizes, etc. But what I tried to give you was the base at 10 to the -0, and then notice that I went by 3s as I went higher. I went 10 to the 3rd and then 10 to the 6th. Below, I went -1, -2, -3, and then once I got to that -3 place, I went by 3s again, 6, 9, 12. You're going to have to know these prefixes. I'm hoping that just this little pattern is something that is something that you can use to help remember.